Okay, next we're going to get into some applications. Now that we've talked about angles, radians, and things like that, we're now going to look at a few examples of where these come into play. So the first one is arc length. So arc length is basically how far it is on the outside of a circle, and we're going to use S to indicate that. We want to come up with a formula that we're going to use. So the book mentions a formula, however I want to show you a kind of little derivation where it comes from here. So I'm setting up a ratio is how I want to accomplish this and get the formula. I'm taking the ratio of the whole circle to part of the circle. And the ratio I'm using, I'm taking the circumference, which would be the length all the way around the outside of a full circle, divided by the angle measurement for a full circle. So if I have the full circle all the way around here, that's going to be 360 degrees. That's our 2 pi radians we talked about earlier. So for this one, you're going to take the same type of ratio. We're still talking about how far it is on the outside of the circle, but we don't have a full all the way around the outside. We don't have a circumference this time. We only have part of it. That's going to be right there. That's your S. On the bottom, that's your theta. That's going to be your central angle there. So here is our formula that or proportion that we're going to be using. The circumference, though, we do have a formula for that. That's going to be 2 pi r. And so I have 2 pi down below. So 2 pi r is your circumference formula. 2 pi is from our proportion we set up. And then I still have my S over theta. I'm going to cross multiply to get it out of the fraction form. So I have S times 2 pi, and that's going to equal 2 pi r times theta. Now I want to solve for S. So I'm going to divide both sides by 2 pi. Now when that happens, both those pi's, the pi and the 2's are going to cancel. And what do we get? We get the formula for arc length. The formula for arc length is S equals r times theta. And your theta, this must be in terms of radians. So the one they give in the book has radians only. So if you're going to use this, we're using that. Now, of course, if I wanted to come up with a version that would be used for degrees, I certainly could do that and put 360 down below there, and I would have a 360R there. But instead of worrying about that, instead we're going to just leave it like this. And then this is going to be your formula primarily for radians. So now that we looked at our formula for arc length, S equals r theta, we'll now look at a couple of examples. Okay, so now we're going to do some problems practicing arc length, finding the arc length, and also finding the area of a sector. So here's one that we'll do that deals with arc length. Find the central angle of an arc whose radius is 6 inches and whose arc length is 2 pi inches. Let's draw a picture that kind of visualizes what's happening. So we have this right here. They're telling us that the radius is 6, and they're saying that this here is 2 pi that goes all around. So that section right there is 2 pi. What we're trying to find, we want to find out what is the theta that allows us to work. So the formula that we talked about earlier was your S is equal to r theta. Your theta would have to be in radians. Your r is your radius, and your S is your arc length. They tell us the arc length is 2 pi. So I'm going to put 2 pi in there, and I'm also going to put the units in there as well. So 2 pi inches is going to equal 6 inches, and then that's going to be times theta. I want to solve this for theta, and that's going to give me my answer. So divide both sides by 6. I get 2 pi over 6 is your theta. Now what's happening here is I'm dividing both sides by 6 inches. So the inches cancel out. So actually we just get 2 pi over 6, which is the same thing as pi over 3. Now that's going to be our answer. So pi over 3 equals theta. That's what we're going to put for our answer. So this would be a radian measurement because we got the pi in there. But one thing I want to point out here is notice that both of the units canceled out. So technically pi over 3, even though it's a unit of measurement, we could use it to measure angles, we say that this is actually going to be a dimensionless quantity because the inches both cancel out. So that's going to come back a little bit later when we start putting in the units on this. We're going to say that this is actually a dimensionless quantity, meaning that we're not going to have any units on that. So even though it's radians, we're measuring angles in terms of radians. Later on we'll talk about some problems where you're actually not going to put in radians and it's going to be a dimensionless unit. So you'll see some examples like that later, but I wanted to point that out Again, because the inches cancel out, that's why we don't have any units on this one, even though we said that's a measurement for angles, and we call it radians. Okay, here's another one with arc length. Find the arc length of a sector whose radius is 7 inches and whose central angle is 45. Here's the same formula we just used previously, S equals r theta. And we want to put in the information that's given. Now, 45, we don't want to put that in for theta. The reason why is because this formula here only works if you're in radians. So I first need to take 45 degrees and I'm going to change it over into radians by using the conversion on that. So I have 45 degrees, pi over 180 is my conversion. If I reduce that, I get pi over 4 radians. So pi over 4 is what I'm going to use when I put it into the formula itself. So arc length is what we're trying to find. So this time we're solving for S. Okay, your radius is 7 inches, and then I have pi over 4, which is going to go inside there for theta. Now, what I just mentioned earlier was that the radian is a dimensionless unit on this. So when I multiply that out, because this is considered dimensionless, I'm not going to put an RAD after it. It is radians, yes, but it's dimensionless, so I'm going to leave that off. So when I multiply that together, I get 7 pi over 4. Because there's inches here, that means that I'm going to have inches also for my answer for arc length. And that would make sense. If I've got this right here and this is 7 inches along there, and I want to figure out how far this is, that means that's going to be a unit of measurement also, how far it is from here to here. Well, that's going to have to be in terms of inches as well to match that one, so that's why those two would have to match. And again, it's all because of the radian there is considered dimensionless units. That's why we just have inches go along there as part of our answer.